Okay, so today I'm going to be just running through the 2018 Leaving Cert paper for maths, paper 1, and I'm just going to be looking at question A. So the first part of question A, question 1, question A here, asks you to solve 3 simultaneous equations. So when we have 3, we see that the first 2 simultaneous equations, these 2 here, are equations in 3 variables. So you've got x, y, and z. And then the last one, the thing that kind of stands out to me is that this is only in 2 variables. So you've got the x and then the z. So the strategy for these is to take the 2 equations that have all 3 variables in it and try eliminate the variable that's not in the third equation. So you see here there's no y. So what we're going to do is we're going to take these first 2 equations and eliminate the y from them. So what I'm going to do is I'm going to name the equations 1, 2, and 3. So we'll just call this one equation 1, equation 2, and equation 3. So it's good just to label your work as you go along to make it nice and clear. So we're going to be taking equations 1 and 2, and we're going to eliminate y from them. So we've got 2x plus 3y minus z is equal to minus 4, and then we've got the 3x plus 2y plus 2z is equal to 14. So to eliminate the y's here, the thing that kind of stands out to me is that they're both 3 and 2 are factors of 6, so that's what we're going to use to eliminate them. So we can see that if we multiply the first equation by 2, we'll get 6y. And if we multiply the second equation by minus 3, we'll get minus 6y, and thus they will cancel. So let's do that. So we've got equation 1 multiplied by 2, and that is 4x plus 6y minus 2z is equal to minus 8. And then the second one, we're going to multiply equation 2 by minus 3. So we will end up with minus 9x minus 6y and minus 6z is equal to 14 times 3 minus 42. Now combining those 2 equations, we see immediately that the 6y and the minus 6y will cancel, which is what we wanted all along. And then our end result is going to be minus 5x, just adding the 4 and the minus 9, and then minus 8z. And then we've also got equal to minus 8 and 42, which is minus 50. So what we're going to do now is we're going to call this equation number 4. So now we've got, if we look at equation 4 here and we look at equation 3, we see that they're both simultaneous equations in 2 variables. So that's just your ordinary way of solving them, the same as usual. So what we're going to do is we're going to write equations 3 and 4, and we're going to either solve them for x or for z, it doesn't matter. Usually one way is easier than the other. So we've got x minus 3z is equal to minus 13, and we've got minus 5x minus 8z is equal to minus 50. So if we multiply the top equation by 5, we see that we'll get a 5x, this will cancel then with the minus 5x below, which would leave us just with an equation in z, which we can solve for z then. So we've got 5x minus 15z is equal to 5 minus 65, and then we've got minus 5x minus 8z is equal to minus 50. So again, just like we wanted, we get the cancellations of that, and then we're left with a 15 minus 23z is equal to minus 115. So then to get just z by itself, we divide both sides by minus 23, and minus 115 divided by 23, so that it leaves z is equal to 5. And what we're going to do is we're just going to highlight that because we'll need it for later. So perfect. Oops. So next off, we are going to sub z is equal to 5 back into either equation 3 or 4 to find out what x is. So I'm going to do equation 3 just because it's easier. So we will have that x minus 3 times 5 is equal to minus 13. So that will be that x minus 15 is equal to minus 13. So x is equal to 2. And again, I'm going to highlight that. And then lastly, what we're going to do is we're going to sub z is equal to 5 and x is equal to 2 back into equation 1 to obtain a value for y. So we will do 2 times 2 for x plus 3, y minus 5 for z is equal to minus 4. That gives us 3y is equal to minus 3. And then dividing both sides by 3, y is equal to minus 1. And again, we'll just highlight that as well. So that's our final answer there. So we've got that x is equal to 2, y is equal to minus 1, and z is equal to 5. And to check that, you can sub those three values into the three equations that we began with up at the top, so equations 1, 2, and 3. And if you sub them into the left hand side of each equation, you should get the right hand side out, and that's how you know you're right. Perfect. So now looking at question 2. So in question 2 is all about inequalities. So we're asked to solve the inequality, this inequality here, which is that 2x minus 3 divided by x plus 2 is greater than or equal to 3, where it says x is an element of the real numbers, so that's what that symbol there means, just that x is an element of the real numbers, which are basically all the numbers including irrational ones like the square root of 2, and also all the whole numbers, the minus numbers, everything. And also that x is not equal to minus 2, and the reason x that's stipulated there is that because if we take a look at the bottom of the fraction, x plus 2, if x was equal to minus 2, we would have a 0 on the bottom, which we know that you can't divide by 0, so that's why that has to be stipulated there. Okay, so we're going to write out the inequality. So we've got that 2x minus 3 divided by x plus 2 is greater than or equal to 3. So the thing with inequalities is that we cannot multiply or divide by a minus number. So we don't know, we're trying to find out what x is, that's the aim of the game. So for all we know, x plus 2 could be potentially a minus number, so we can't just multiply up by x plus 2, and that is a common mistake. So what we must do instead is we must multiply both sides by x plus 2 squared. And the reason we do that is because we know that x plus 2 squared is always going to be greater than or equal to 0, so it's always a positive number. So let's do that now. So we'll multiply both sides by x plus 2 squared. So we've got 2x minus 3 by x plus 2 squared divided by x plus 2, which is greater than or equal to 3 times x plus 2 squared. So we can divide the top and bottom on the left hand side by x plus 2. So that leaves us with 2x minus 3 times x plus 2, which is greater than or equal to 3 times, multiplying out the squared, x squared plus 4x plus 4. And again, once we multiply everything out, we get 2x squared minus, what am I doing? Plus 4x minus 3x minus 6 is greater than or equal to 3x squared plus 12x plus 12. And what we're going to do now is we're going to take everything on the left hand side here and we're going to bring it over to the right hand side. So we get, once we do that, that x squared plus 11x plus 18 is less than or equal to 0. Now this is just basically an ordinary quadratic equation, so we can solve for the roots, which gives us x plus 9 times x plus 2 is less than or equal to 0. So the next bit, that what we do now, it's a little bit mightn't seem obvious is what we do is basically we solve for the critical values. So these are going to be form our final inequality, which is our final answer. So how we do that is we literally just write it as an equation. So we do x plus 9 times x plus 2 is equal to 0, which gives us x is equal to minus 9 and x is equal to minus 2. So now what we need to know is if I draw out the number line down here, and we have a minus 9 here and a minus 2 here. So we need to know if we're looking at the region in between minus 9 and minus 2, or if instead we're looking at the region either side. So how we know that is what we do is we take a test value. So that's any value that's in between minus 9 and minus 2, and we test it and see whether the original inequality holds. So what we'll do is we're going to use, say, x, I'll write it in blue. So we'll try x is equal to minus 3, but you can choose any value in between minus 2 and minus 9, and we'll sub it into the original inequality. So we'll get 2 times minus 3 over minus 3 plus 2, which is equal to minus 9 over minus 1, which is equal to 9, which is indeed greater than or equal to 3, so that's a big tick. So we see that for a value in between minus 9 and minus 2, that the inequality, the original inequality up here holds. So for that reason we know that the answer is that minus 9 is less than or equal to x, which is less than 2. And the reason this is kind of important here, if I'll just highlight it there for you, the reason it's a less than and not less than or equal to is because of this original stipulation that x is not equal to minus 2. Oh, I completely forgot a minus there, but that should be a minus. So yeah, so that's why there's no less than or equal to, it's just a less than because x is not equal to minus 2. So yeah, I'll just leave that there if you want to screenshot it or anything.